In this video, we'll discuss factors in solubility. So remember, solubility is the ability to dissolve. Factors would be temperature, stirring, crushing, and pressure. So first you have stirring, which, we could say agitation. That could be shaking, stirring, mixing, anything like that, where you're moving the particles around quickly. It doesn't affect the amount of solute that's being dissolved, but it does decrease the time for it to dissolve. And the reason this happens is because the collisions that occur between the solvent and the solute, they increase. So it increases the rate of those collisions, which make the solute dissolve. Surface area or crushing. So when you crush the solute, you increase the surface area. So instead of having a block of sugar like this, you have a whole bunch of little bitty, not blocks, but little chunks. And if you calculate the surface area to volume ratio, these have a higher surface area to volume than a big chunk. And so again, this does not affect the amount of solute that can be dissolved. It just speeds up the rate of dissolving. Pressure and solubility. So pressure above the surface of the solvent affects the solubility in gas. So if you have a gas that's being dissolved, like Coke or Dr. Pepper or any carbonated beverage, if you have high pressure above the surface, then it increases the solubility. So high pressure pushes the gas particles into the solution. Low pressure allows them to escape easier. And if you think about a can of Coke, that's what you see. Once you open up that can, you decrease the amount of pressure, and that allows for all that gas to escape. Temperature and solubility. Now this is kind of the outlier, because not only does it increase the rate, if you increase the temperature, it increases the rate of solubility, but you can actually add more solute to the solution and it will dissolve. If you increase the temperature, it increases the rate and the amount that can be dissolved. And we look at solubility curves to document this. So here's an example. We're going to look at potassium chloride. So here's our curve for potassium chloride. Notice that we have our solubility. This is the amount that's being dissolved in 100 milliliters of water. Notice that this says grams of salt in 100 grams of water. Well, 1 gram is equal to 1 milliliter if you're talking about water, because the density is 1 gram per milliliter. So you could interpret this as 1 milliliter of water. And then this is the temperature. So if hypothetically we had 40, maybe 41, 42 grams of potassium chloride at around 49 degrees Celsius, if that amount dissolved, then that means that that solution is saturated. If it's right on the curve, if your point is at any point on this curve, that would be saturated. But if it's below the curve, that would be unsaturated. So that means that we could add more solute and it would still dissolve. Supersaturated, well, if you're able to dissolve 50 grams at 60 degrees, well, that's more than the saturation point. So what happened is it had to have been heated up originally, and then it cooled down to 60 degrees. That would be a supersaturated solution.